Hello everyone, this side Dr. Nitin Sharma, Associate Professor, Department of Information Technology, Ajay Kumar Engineering College, discussing about a topic that is Turing Machine, which is from the Theory of Automata and Formal Language. So, first of all, I just talk about what is Turing Machine. So, Turing Machine basically is having a machine which we can say that we can create a suppose this is the block diagram. Okay, so this is the input tape and this is having a controller and this is the head. Okay, so this controller is having the transaction functions which can take the input from the input tape. And what is the major power in this automata is that head is moving from left to right and right to left. So head is moving both sides. And the second major point is that it is not this head is not able to read only, it is also the write on that particular tape. So that's why this is becoming a more powerful machine. So first we understand, generalize the classification of context free language. So you can see these are the classification of languages. So first of all, I am talking about a regular language. So regular language is basically understand by the regular basically construct by the regular grammar, and it is understanding by the finite automata. So finite automata that can understand the regular language, which is having some limitations, right? If we remove some limitations, so the next language is becoming a context free language. That context free language which is basically understood by the push down automata. So this push down automata can understand the context free language, which is basically if we can see this Venn diagram. So in this diagram you can understand that whatever language is a context free is also a regular language. But if some language is a regular language, you can't say that it is a context free language, right? It is recursively language. Recursively language is which is understood by the lower bound automata. And next is recursively or non-recursively, or we can say that unrestricted grammar, which is basically understood by the Turing machine. So today we discuss about the Turing machine. What is Turing machine? How we can design the Turing machine? So today I am going to discuss about it, right? Next, so you can see this is the block diagram which we can introduce here. This is the input tape which is having some input symbol. B is represented here is a blank spaces. 0 and 1 are the input symbols. And this is the finite controller which is having the transaction functions. That transaction functions is basically known that what symbol we should read currently and what we have to do in the next step. Either we have to move from left to right or right to left, and we have to read only, or either we have to write only. These are the things every transaction function should know that. Okay, so the things are, so how we can define a discrete Turing machine. So discrete Turing machine which is defined by the 7 tuples q, sigma, tau, delta, and q0, b, and f. So what is q? Q is like a set of finite set of states. So in the automata, suppose there are 10 states, so we can say that q is a set of 10 states. Okay, what is sigma? Sigma is a set of input symbol, either 0, b, or we can say that the a, b. What are the input symbol we are using here? That are the part of a sigma, right? Next is tau. Tau is a tape alphabet which is strictly superset of a sigma. So tau is basically, suppose we are having here sigma is equal to 0, 1, right? So what is tau? Tau is basically what are the symbols you are going to be used on a tape that are basically the part of this set. That means it is also having a, it is also, we can say that the superset of a sigma. So like 0 and 1 also included here. And suppose when you are reading that input tape which is having a symbol of 0, 1, and you are writing either A or B in the place of 0 and 1 simultaneously. So you can also include here, like I can write X and Y in the place of 0, in the place of 1, and the another one more alphabet we are using here, B. B is basically representing the blank here. So this set is called as a tau. So I can just write here a finite tape alphabet which is a strictly superset of a sigma, right? What is B? B is basically the blank symbol which is in tau, obviously, like I have already written there. So B is a blank symbol which can represent that the input tape, in the input tape, the string is completed, and draw blank is basically represented that this is the blank space started, right? When you are going to read a string, so suppose there is a string like this one, B 0 1 0 0 B. So how could you know that the string is completed? When you get the B blank space, that means the string is completed. B cannot be put in between of the string, right? What is Q0? Q0 is basically represent the initial state. Initial state of any automata, it is represented by the Q0. F is the set of final state, which is basically a subset of Q, or in an automata, we have more than one input. We can have a more than one final state in a particular automata. Next is delta. Delta is a transaction function. The mathematical configuration is, so this is basically represent that any one symbol from the Q, any another symbol from the tau, it is basically for the equivalence sign. It is not equal to the equal to, right? Like this one and this one is both are different. This is basically representing that in the mathematics, this value is equal to this one. But this arrow is basically representing that the value it tends to or goes to. So this state, suppose there is a one state from we can get from the Q, and one symbol we can take from the tau. So if we combine them, like the state is reading a symbol, then it goes in another state, like any state from the Q, any input symbol, and next is the movement. Either it goes from the left to left movement or the right movement. So this is basically the way of representation of a transaction function. Okay, so for example, we can show here, suppose delta, there is one state Q0, reading symbol is A, it goes to next state is, we can say that Q1, for example, okay, and in the place of A we can write X and we can move for the left. So this is the way you can represent any transaction function in a automata, okay, in a Turing machine. Next, now understand with an example. So like in this example, you can see what language says that, okay, you have to design a Turing machine for the W. W is in 0 or 1. That means W is making a string with the combination of 0 and 1, and W end with a 0. So like you can see there are some example here. So like when I take a AND with 0, when I am talking about a AND A with and a 0, so the string should be AND with 0, 0, 0, 0. So these are the example which the string is AND with 0. Okay, and the automata is designed here. This is basically representing the transaction table. Transaction table, we are having here the present state. These are the present state. These are the tau symbol. So initial state, when it is reading a 0 input, it go to the next state, that is also a Q0. It is a self loop. So in the place of 0, it can write 0 and move to the right side. Okay, so this is the way the table is designed here. Okay, and how you can design a graph. So graph we can design like Q0 is a state, and if we can draw this one, so 0 input, 0 or R. So this is basically you can represent on a transaction edges. Okay, or another way you can represent, there are so many ways you can represent here, either 0 or 0R, or another way you can represent 0 upon 0R. So this is the way you can represent the transactions on particular graph. Okay, for the fully explanation, I can explain with an example. You can understand better, okay, how you can design automata, how you can transaction on a transaction graph. Okay, in the next example, you can just listen carefully so you can understand how you can design an automata. So this is the example where I am going to design an automata for the language L is equal to A to the power n and B to the power n. Okay, so this is the example I just want to create it here. What I am going to it, so the concept is that I am writing a string here, A, B, B. What I am going to do is, I am going to I am starting from here. In the place of a, I am going to write a x. Then move till this one. I am writing here y, and then move to the left side. Then go till here, then move here, then I can write here x, then we move till here y, then x, then y, then the total transaction is going to be completed here. Got my point? So this is the way I can just write this one. Another is I just read here blank. Okay, so blank we can write here like these delta, we can write, we can represent here b. Okay, so this delta is representing a blank. Okay, so you can understand the graph. So this is basically the initial state, this is the graph, this is the complete solution here, right? Understanding line by line how this graph is generated. Okay, so step by step we are going to understand how this graph is generated, how we can understand that how the initial state start the process to read the symbol. Okay, next. So initially you can see this is the string time 0. So initially these are the deltas, or we can say that the blank spaces, and the starting symbol is a, right? So Q0 is the state, it is reading a symbol, tends to what they are doing, they just transfer from Q0 to Q1 and writing here x, right? So this is the transaction function done we have here. Q0 is reading a, I can write here x, move to the right hand side, so pointer is going to that side, and the state is become a Q1. Why we change the state here? So the concept to change the state here, whenever some process has to be changed or some process you are going will be changed, you must change the state here, right? So what I am doing here, what my concept is, I am telling you my concept is that initial state or whatever state is reading a symbol, and if you are writing something on that, like there is a symbol a and you are writing a x here. So if you are writing something, you should change the state here. That is the first point. There are so many points when you whenever you are going to be change a state, there are so many points. So one point you must be consider that whenever you are writing something in place of a variable like a, you are writing a x, you should change the state. So I am changing the state here. Got my point? This is the first step. Next, this is the x become now, and you are on Q1. Whenever Q1 a is read there, what you should be done, you should skip them, right? I don't want to do anything this a, or multiple a are coming. Suppose the value of n is 10, so there are 9 a are coming, so I don't want to be doing anything with this a. I just move that till when I got the b. So Q1 a, so Q1 a is reading a symbol and it is a right move. So it is a, then go to the right hand side and Q1 here, right? And you can see when I take a input a and writing is a, that means skip. I am not going to write anything here, so there is no state change here. Got my point? So the next is Q1b. Now Q1b, what Q1b do? Again we have to be right here y, right, y. We have to move left side and we have to change the state, that should be Q2. Why we should change the state? Because we are writing something. So what same thing we have done here. You can see here Q1 is reading a b, we are writing y, moving left side and goes to the Q2 state. Got my point? Understood? So this is we have done, and now we have a Q2 on a. In the next step you can see here what you have to do with this Q2. We have to be just move, because I don't want to write a, because in this example we have a 2a, suppose we have a 3a, so this is the last one, then again 1a more a, then we can got the x. So how we can know that number of a is designed till then? So we have to be move till we got the x. So what we have to do, Q2 a left side. So we can write in the place of a is a left, then move left, then Q2 is coming here. So this loop is running until all the a are coming here, till I am going to the till the x. Got my point? Next point. So now when the all A is completed, we are coming here. Okay, what we have to do? So there are one cycle is completed, like there are something which are going to be in a cycle phase, like in the A we have to be write X, then we have to write B, Y, then X, then Y. Okay, so this is the process we are going to be run here. Like I can take one more example, like A, B, B, B. Okay, so there is something which is running continuously in a loop. Like what? We have to be right here X, then Y, then X, then Y, then X, then Y. So this is the process which is continuously running. Got my point? So what happened? When I come here, we have to be start from the initial state. Why? Because the one loop is completed. Now we have to be run again and again the same thing. So what we have to do? Q2 is doing X in the place of X, means we don't write anything here, but we have to be go to the Q0. So we have to be write here from the initial state Q0. Okay, so in the place of X we can write here X, and we move to the right hand side. Okay, so we move from left to right hand side. Now in the next Q0A, again you can see the same function, transaction function will run here. Q0A, we can write here X and right move. So we can write here X and we can go the right move, that is Q1. Now Q1Y, what Q1Y? Q1Y, Y right move, because I don't want to do anything with this Y, we just move here. So Q1 move here, right? In this you can see Q1Y. So Q1Y, what is it? Y tends to Y R. So we can just move forward from here to there. Now next, when Q1B, it is this transaction function is already designed. So what we are doing here, Q1, when it is reading B, so B tends to Y, so we have written there Y, and move left hand side, and the state is Q2. So in the next state you are reading Q2Y. Okay, now you can see all the X and Y, all the X and Y are written there. That means all the A and B are processed. So what we do next? We have to be checked, okay, all the A is covered. Once the Q0 is going to be read Y, that means all the process has been completed. Why? Because if Q0, when Q2 is here and Q0X is reading, or Q2X is reading, it is going to the initial state. Once Q2 read is, that means whenever Q2X is reading, it is go to the Q0. So Q0Y is reading, it means that all the A is completed. So n number of A is completed, that means n number of Y also be completed then. Okay, let's see. Q2Y is YY left. So we can just go here, this one. Got my point? Next, what Q2X do? Q2X is already designed. Whenever I'm going here, get here X, I'm going to Q2X, X tends to X right. Okay, so what it do? It is basically reading this symbol, and in the place of X, it is writing X only. That means there is no overwriting here. It is goes to the right hand side and go to the Q0 state. So whenever Q0 is reading a Y symbol, that means Q0 is not reading the A symbol. That means A symbol is all written A. Okay, so if all of them are written A, that means n number of A is written X, n number of written Y completed. So what we should do? We should move from one state to the another state and skip all the Y's. What we are doing here? You can see when Q0Y is written. So what I am doing? Q0Y tends to Y. That means Y ke place par we can write in Y only and move from left to right. So we can just write here Q0. So we can just change the state. Why I am changing the state? Because if I am taking a self loop here, so without A, it can be executable. So what we have to do here? we have to be just move this one Q3. Okay, so we just go to the Q3. So Q3y is self loop in the next loop. So Q3y, you can see the next loop. So any number of y is running there. Suppose there are 5, 6, 7, whatever y is there, they are running a self loop, right? What next? When Q3y is running a y, so at one time Q3 is studying or reading a delta. So what delta is? Delta is basically a blank symbol, right? Blank symbol, whenever Q3 is reading a blank symbol, it can write a blank and go to the QF, or we can say that the Q4. This is the final state, double circle, and move to the left side. Or we can just change here right side. We can just go from this side. So Q3 is whenever reading a delta, it is going to the final state, right? Q3, Q4 here. So that means it is completed here, right? Now, this question is designed for the L is equal to A to the power N, B to the power N. What is the value of N? N should be greater than or equal to 1 only. This answer is feasible if the value of N should be greater than or equal to 1. That means at least 1A or 1B should be there. We can just run here. Okay. So Q0 is A reading. It's coming here, right? After that, it's reading B. So in the B, we can write here. Then it can right, then left. Then left means it can read again X. So it become here. Then it read Y. It become here. Then it become delta. Then it can be move here. Okay. So this is the way the process is running. Now my question is for you. You have to design by yourself the same question. L is equal to A to the power N, B to the power N, for N should be greater than or equal to 0. You can design for this, for the Turing machine. Okay. If you can get this answer, you can just post on my comment box so we can check. Okay. Thank you so much. Thank you.